A long time ago, the continents, as we know them today, were not yet separated. North America, South America, Africa, Asia, Europe, Australia, and Antarctica were once connected as one huge landmass called Pangaea. And in fact, this didn't happen just once. What do I mean by that? According to scientists and geologists, the continents have repeatedly come together and separated over billions of years. They call this the supercontinent cycle, a very long process where the landmasses of the world slowly come together and then eventually break apart again. And the reason for this is right beneath our feet. The surface of the Earth is not just a single solid piece. It is divided into huge sections called tectonic plates. They're like giant puzzle pieces that slowly move on top of the hot and almost molten part of the planet. They move very slowly. Sometimes they move only about as fast as a human fingernail grows in a year, but even though they're slow, their effects are powerful over millions of years. When these plates collide, mountains can form, new land can appear, and powerful earthquakes and volcanic eruptions can start. But when the Earth was young, the planet was much more chaotic and hotter than it is now. According to studies by geologists, the surface of the world was almost entirely ocean back then. There was very little solid land, and the first parts of the Earth's crust were thin, hot, and easily sank back beneath the surface of the world. There was very little solid land, and the first part of the Earth's crust was thin, hot, and easily sank back beneath the planet. When parts of the oceanic crust collided back then, one part would be pushed down beneath the Earth, and as it sank, the rock melted and turned into magma. Afterwards, the magma would rise back up to the surface. This is where the first volcanoes and small islands of the ancient world began to form. Something similar is happening today in some volcanic island chains like the Aleutian Islands in Alaska and other places in the Pacific Ring of Fire. Over a very long period of time, these small pieces of land gradually came together. As the tectonic plates continued to move, some parts of the crust became thicker, stronger, and more able to survive the intense heat beneath the Earth. And this became the foundation of the first true continents. This didn't happen in just a few years or centuries. It took billions of years. And as these ancient landmasses grew, Earth's climate, ocean currents, and even life on the planet also began to change. According to scientists, supercontinents have a huge impact on the entire world. But why? When almost all the land is connected, the movement of air and water in the oceans changes. The temperature of the planet also changes. There are places that become extremely hot and dry because they are very far from the sea. Meanwhile, other areas experience intense storms and heavy rainfall. And as the continents separate again, new seas, new oceans, and new habitats for different kinds of life are formed. That's why the way the world looks today is not permanent. The continents are still moving to this day. But wait, let me pause for a moment. Before we continue the discussion, I'd like to ask for a like and please subscribe as well. This is a big help for us content creators. Thank you. So, let's get back to it. If we look at the map of the world today, it seems like the continents are permanently fixed in place. But in reality, they're just moving very slowly. And beneath these countries, there are parts of the land that hardly change even after billions of years. Scientists call these Cratons. Cratons are the oldest and strongest parts of the continent. They're like the foundation of modern countries and continents today. While many parts of the Earth repeatedly melt, break apart, or sink into the planet, the Cratons remain intact. According to geologists, it's possible that some of these formed more than 4 billion years ago. This means they are even older than most of the mountains and oceans we see today. The reason why Cratons are so strong is because their roots go very deep beneath the Earth. They are thicker than the planet's ordinary crust. Their composition is also lighter, so they don't easily sink into the hot mantle beneath the Earth. It's like a huge chunk of hard rock floating on top of the hotter and softer part of the Earth. Because of this, even though tectonic plates move over a very long period of time, the Cratons are still able to survive. One of the well-known ancient Cratons today can be found in Canada. It's called the Slave Craton. Aside from being rich in diamonds, minerals, and precious metals, it is also important because some of the oldest rocks on Earth were found here. This includes the Acosta gneiss, which according to studies is almost 4 billion years old. This means that it is possible that it was part of the very first stable landmass formed on the planet. On the other side of the world, in Western Australia, you can find the Pilbara Craton. This is also one of the oldest parts of the planet. But what's even more surprising is that traces of ancient life have also been found in this place. According to scientists, there are fossilized microbial structures there that may be among the earliest evidence of life on the planet. And it's not just Australia that has this kind of ancient rock. In South Africa, there's another very old place called the Craton. Rocks and biological signatures almost as old as those in Pilbara were also found here. But what's even more remarkable is what geologists noticed. Even though Australia and South Africa are very far apart now, they have rock formations, mineral deposits, and mountain structures that are almost identical. It's as if they were once connected. Because of this, some scientists believe that these two places were once part of a very ancient supercontinent. They called it Vaalbara. According to some geological reconstructions, it's possible that it formed more than 3.5 billion years ago. It's much older than Pangaea. At that time, Earth was very different. There were no plants, no animals, no forests or grass yet. The world back then was probably full of volcanoes, thick smoke, intense heat, and a rocky environment. And while this was happening on the surface of the planet, it's possible that the very first simple life was just beginning to form under the ancient oceans. In 1976, scientists first noticed that some mountain belts and rocks in South Africa and Australia had similarities. At first, they thought maybe these just had the same age, which is why they look similar. But as scientists studied them more deeply, another explanation emerged. In 1996, geologist Eric Chaney suggested that it was possible that the Kopval and Pilbara Cratons were once connected, and from this, the idea of Vaalbara was born. Until now, scientists are still studying whether this was really Earth's very first supercontinent. There are also other theories that say there were even older continental formations before this. Because these events happened so long ago, it's very difficult to find complete evidence. And these ancient Cratons serve as the remaining traces of the very first chapter of our planet. In fact, according to geologists, there are ancient lands that have long disappeared and are almost unrecognizable on the modern map of the world. One of the most controversial ideas about this is what is called Ur. This is not the Ur from movies or legends. This is a hypothetical proto-continent proposed by the geologist John Rogers in 1993. According to his theory, there was an ancient land made up of different ancient Cratons from Africa, Australia, India, Antarctica, and other parts of the world. This supposedly included parts of Western Australia, South Africa, India, and even Madagascar. But there's a big problem. Not all scientists agree on what this ancient world looked like. Some researchers believe that parts of South Africa and Australia were once connected in a supercontinent called Vaalbara. But in Rogers' reconstruction of Ur, those places are far apart and located on different parts of the ancient land. This means that both models can't be correct at the same time. Scientists are still debating this issue today, and because these events happened so long ago, it's really hard to find complete evidence. Many of Earth's ancient rocks have long been erased, melted, or sunk deep beneath the surface due to tectonic activity. But even though we're not yet sure about the exact appearance of the first continent, there are some things that are clear from studies. At that time, there was almost no life on the surface of the Earth. The world back then was extremely hot, with many volcanoes and thick smoke in the atmosphere, and most of the land was rocky and dry. It's also possible that some of these ancient lands were located near the equator because the planet's tectonic movement was more active back then. As time went by, the Earth began to change and the planet's crust gradually cooled. Because of this, it became possible for larger continents to form than before. According to geologists, around 3 billion years ago, different cratons from various parts of the world began to come together. This included some ancient parts of North America. One of the most important additions at that time was the slave Craton from Canada. After this, other ancient parts of Europe and North America also gradually joined together. As these cratons collided, large mountains, fault lines, and volcanic regions were formed. It's like a giant collision of slow but extremely powerful pieces of land. And from this series of collisions, one of the most important was formed, Earth's very first true supercontinent. Scientists called it Kenorland. According to some geological reconstructions, it's possible that it covered a huge portion of the available land on Earth at that time. It was even larger than most of the modern continents today. It is said to have included the ancient parts of North America, Greenland, Scandinavia, and some parts of Asia. Because of the numerous collisions between cratons, volcanic activity and mountain building were also active on this supercontinent. And while that was happening, another important change was taking place on Earth. Simple forms of life were beginning to multiply in the oceans. These were not yet fish or animals. Most of these were microscopic organisms and bacteria that lived in shallow water. But even though there was only simple life back then, they were immediately affected by changes on the planet. Because Kenorland was so massive, it changed the movement of air and oceans on Earth. Some parts of the sea became colder. There were also places that became difficult for simple organisms to live in. And after a very long time, Kenorland began to break apart. According to scientists, Earth's tectonic movement became more active as the planet's interior continued to change. The supercontinent gradually developed large cracks. As its parts separated, new oceans began to form. And this marked the beginning of one of the biggest changes in Earth's history. As the new seas expanded and rainfall intensified, rocks on land were broken down and eroded more quickly. Because of this, carbon dioxide in the atmosphere decreased. And that was a big problem in ancient times. According to studies, the sun's heat was weaker back then compared to today. So when greenhouse gases in the atmosphere decreased, the whole planet cooled rapidly as well, until a severe ice age set in. According to some theories and geological evidence, it's possible that even the oceans near the equator froze over about 2,400,000,000 years ago. Some scientists call this Snowball Earth, a period when most of the planet was covered in ice. But it wasn't just the climate that was affected. While the world was freezing, Earth's atmosphere also began to change. Oxygen in the air gradually increased because the oceans could no longer easily absorb the oxygen produced by ancient microorganisms. And even though oxygen is important for life today, at that time it was dangerous for most ancient organisms. Many of them could not survive in an environment with high oxygen levels. That's why a large portion of ancient microbial life disappeared. But some organisms were able to adapt. And according to scientists, these surviving organisms became the foundation of more complex life on Earth. From simple cells, the very long process slowly began, which would eventually lead to the emergence of plants, animals, dinosaurs, and ultimately humans. After the ancient supercontinent Kenorland broke apart, Earth did not immediately become peaceful. For hundreds of millions of years, the pieces of the continents continued to move across the planet, like giant slabs of rock drifting very slowly across the surface of the Earth. And as these ancient cratons traveled, they once again began to come together in different ways. According to geologists, some parts of these ancient cratons came together, while others drifted completely away. While this was happening, another important change was taking place in Europe and Asia. The very first version of Europe was slowly beginning to form. Scientists call this Baltica. It was not yet like the Europe we know today. It was just an ancient landmass made up of old cratons from the northern part of the Earth. At the same time, there were other continental fragments that also traveled to the colder parts of the planet. There, they encountered other ancient lands from Siberia, Greenland, and Europe. And when these came together, they formed a cold and very ancient protocontinent called Arctica. Yes, almost like the name Arctic, because according to some reconstructions, it's possible that it was located at high latitudes or colder parts of the Earth back then. But the collision of the continents didn't end there. As the tectonic plates continued to move, Arctica, Baltica, and some parts of ancient North America began to come together. And from there, a larger continental group called Nina was formed. The name means a combination of North Europe and North America. It is said that this included some parts of modern-day Finland, Sweden, Russia, Canada, Greenland, and the United States. As these ancient landmasses collided, large mountains and volcanic regions were formed once again. But even though Nina was already very large, it still wasn't the next true supercontinent. On the other side of the Earth, another large group of Cratons was also beginning to come together. This was Atlantica. According to geologists, this is where the very first core of South America began to form, and some parts of Africa. This included the ancient Cratons that would become the foundation of Brazil, Congo, and West Africa in modern times. While Atlantica was quietly forming in the southern hemisphere, Nina continued to grow in the northern part of the planet. And after a very long period of tectonic plate movement, another major collision occurred. Atlantica, Nina, and other continental fragments from Australia, India, Antarctica, and China gradually came together. And from this, one of the largest supercontinents on ancient Earth was formed. Scientists called it Columbia. Sometimes it's also called Nuna in other geological studies. According to studies, it was formed approximately 1,800,000,000 years ago. During that time, most of the major pieces of the modern continents were already part of this massive supercontinent. This included ancient North America, Europe, South America, Siberia, South America, Africa, and other continental blocks. And because of Columbia's size, it also had a huge effect on Earth. At the edges of the supercontinent, there were large, active subduction zones. As the oceanic crust sank beneath the continent, magma rose up from beneath the Earth. Because of this, a lot of new land and mountain ranges were formed. Little by little, some of the most important parts of the modern continent grew and became more stable. For example, according to geologists, this is when Laurentia, the ancient core of North America, became more complete. At the same time, the formation of ancient continents like Baltica, Siberia, Amazonia, and Congo-Kalahari also became clearer. But like the earlier supercontinents, Columbia was not permanent either. As time passed, large cracks began to form within it again. Tectonic forces gradually pulled apart the separate parts of the supercontinent, and about 1.5 billion years ago, it began to break apart. As the continental fragments separated, a vast ancient ocean formed around them. Scientists call this the Moravia Ocean. And this is where a new stage of the supercontinent cycle began. This time, the continental fragments did not immediately return to their original positions. Instead, they traveled in different directions for hundreds of millions of years. It's like separate pieces of a puzzle drifting apart again. But even though they're far from each other, the story isn't over yet, because in the end, they will come together again to form another massive supercontinent. And Earth's next stage was an ancient world called Rodinia. If there is one supercontinent that is truly important in Earth's history, one of them is Rodinia. Because according to scientists, this is one of the clearest ancient prototypes of the world that would eventually lead to the formation of Pangaea. In fact, before the name Rodinia was officially used, some geologists used to call it Pangaea back in 1970. Because they noticed that it seemed necessary for there to be an even older supercontinent before the continents we know today could form. And in terms of size, Rodinia was one of the largest supercontinents in Earth's history. According to geological reconstructions, it formed more than 1 billion years ago. At its center was Laurentia, the ancient foundation of North America. Surrounding it were parts of Australia, Antarctica, South America, Europe, Africa, and Asia. This means that most of the major continents today were once part of a single massive landmass. And as these continental blocks collided, some of the largest mountain ranges on ancient Earth were formed. According to geologists, some ancient rocks that withstood this collision can still be found today in North America and Europe. There are rocks and mountain formations that serve as evidence of how powerful the tectonic collisions were back then. But Rodinia was different compared to the earlier supercontinents. In the earliest supercontinents, the Earth was mostly filled with volcanoes, rocks, and simple microorganisms. But during the time of Rodinia, life was starting to become more complex. Algae and fungi were beginning to spread in the shallow and wet parts of the land. It wasn't like a modern forest yet. There were no trees or animals on land, but it was a big step for life on Earth. This means that as the continents moved and collided, the planet's ecosystem was also gradually changing. But like other supercontinents, Rodinia was not permanent either. According to scientists, this happened about 850 million years ago. It started to break apart from underneath. It's possible that there was a massive upwelling of hot mantle material from deep within the Earth. Geologists call this a superplume. It's like a giant upwelling of extremely hot rock from beneath the planet. And as it pushed upward, the supercontinent gradually developed large cracks. After that, the continental fragments began to break apart once again. As they moved in different directions, volcanic activity and earthquakes on Earth also intensified. Some parts of Australia and Africa completely broke away. Other continental blocks drifted toward warmer or colder parts of the planet. And because of this, Earth's climate changed once again. As new oceans formed between the separating continents, more rain began to fall on the planet. Gradually, greenhouse gases in the atmosphere also decreased. And just like what happened before in Kenorland, Earth became extremely cold once again. According to studies about 700 million years ago, the planet may have experienced another intense snowball Earth. It was a time when a huge part of the Earth was covered in ice. Some scientists even believe that the ice reached close to the equator. But unlike the earlier ice age, this one didn't last very long. Because while the world was freezing, volcanic eruptions were still happening. And because of volcanic gases, greenhouse gases in the atmosphere increased again. The Earth gradually warmed up again. And as the ice melted, another huge change happened to life on the planet. According to scientists, during this time, more complex multicellular life forms began to appear. This means that it was no longer just simple single-celled organisms that existed back then. Organisms made up of many cells were starting to appear, and that would become the foundation of more complex life on Earth. Eventually, some scientists believe that several continental fragments came together again to form another supercontinent called Pangaea. But up to now, not all geologists agree with this. Some believe that the fragments never really became a solid supercontinent after Rodinia broke apart. Instead, they say the fragments separated in different directions. While some parts of North America, Siberia, and Europe moved northward, Africa, South America, and India, Australia, and Antarctica drifted toward the southern hemisphere. And there, they slowly came together to form one of the most important ancient continents in Earth's history. Scientists called it Gondwana, and over the next millions of years, Gondwana would play a crucial role in shaping the modern world as we know it today. As the pieces of Rodinia continued to break apart, a massive continent was slowly forming in the southern hemisphere. This was Gondwana. According to geologists, it began to form about 800 million years ago from the southern fragments of Rodinia. This included the ancient parts of Africa, South America, India, Australia, Antarctica, and other continental blocks. And while Gondwana was forming, there was also a very important event in the history of life on Earth. This was the Cambrian explosion. During this time, life forms multiplied rapidly, and more complex types of life began to develop in the oceans. According to scientists, this is when many organisms with hard shells, simple eyes, and other defensive adaptations to survive began to appear. It was as if the evolution of life on the planet suddenly sped up. As millions of years passed, Gondwana became even more alive. Plants gradually appeared. Then came the insects. After that, fish and the first amphibians began to spread to different parts of the ancient world. And because Gondwana was so vast, it became home to countless ecosystems. Although technically it may not be considered a supercontinent according to some geologists' definitions, it is still one of the largest landmasses in Earth's history. They say it was even larger than some of the older supercontinents. But while Gondwana was growing in the southern hemisphere, there was also a major change happening in the northern part of the planet. North America, Europe, Siberia, and other northern continental fragments slowly began to come together. At first, an ancient continental group called Euramerica was formed. In some studies, it is also called Laurussia. This is where the so-called ancient forests on Earth began to expand. They were not yet like the modern rainforests, but simple trees and plants on land were gradually increasing in number. Around 400 million years ago, this continental group grew even larger after Sibylium joined. And from here, Laurasia was formed. This would become the northern half of the next most important supercontinent on Earth. Meanwhile, Gondwana formed the southern half. And as the tectonic plates continued to move, these two giant landmasses gradually moved closer to each other. Between them was an ancient ocean that was gradually closing as the continental plates collided. And after a very long period of moving closer, Laurasia and Gondwana finally collided about 330 million years ago. And this is where the most famous supercontinent in Earth's history was formed, Pangaea. Almost all of today's modern continents were once part of this massive landmass. If you look at the map today, you'll notice that South America and Africa seem to fit perfectly together. And that's one of the biggest pieces of evidence that the continents were once connected. But even though the movement was massive, it doesn't mean that the living conditions back then were perfect. In fact, according to scientists, many parts of the supercontinent were extremely dry and difficult to live in. Because the land was so vast, many places were very far from the sea, had little rain, were hot during the day, and cold at night. There were also large mountain ranges that blocked the wind and rain, making some regions even drier. While this was happening on land, there was also a big effect on the oceans. Because of the shape of Pangaea, the movement of ocean currents was affected. Some parts of the sea became too hot for many marine organisms. And according to scientists, this is one of the possible reasons why one of the largest mass extinctions in Earth's history happened. This is now called the Permian extinction. In this event, a large portion of life on the planet disappeared. Many forests dried up and burned. A huge number of marine species completely disappeared, and many ancient animals did not survive. But after this massive disaster, some reptile lineages survived. And from those surviving organisms, dinosaurs gradually emerged. But before dinosaurs completely dominated the Earth, Pangaea also started to break apart. That was about 200 million years ago. Cracks gradually formed between Laurasia and Gondwana, and from there, the Atlantic Ocean began to form. After this, Africa and South America completely separated. While that was happening, India was moving northward. Eventually, it collided with Asia. That collision formed the Himalayas, one of the highest mountain ranges in the world today. Meanwhile, Australia and Antarctica also gradually separated as the Indian Ocean continued to expand. And as millions of years passed, the 7 continents we know today slowly formed. But according to scientists, the story of Earth doesn't end here, because even today, the tectonic plates are still moving.